Welcome back to the deep dive. So if you've ever managed a live event, you know that absolute headache of the audio snake.
Oh, yeah.
All those miles of heavy, expensive copper cable you have to run everywhere.
Mm-hmm.
Today, we're going to dive into the tech that is, well, finally cutting that cord. Our source material is all about a device, it's a real workhorse, called the Thor broadcast F-16A XLR-TxRx.
Right.
It moves 16 channels of balanced audio completely over fiber optics.
And our mission here for you is to really get why pro audio, the lifeblood of concert stadiums, big broadcast events, is making this huge switch.
It's a massive infrastructure change.
It is. And we're not just looking at the features list. We're going to break down the logistical, the economic reasons that make this move pretty much essential now.
Exactly. So at its core, this system is a balanced audio interface kit. You get a transmitter and a receiver.
A super simple concept.
It just takes your standard XLR feeds, turns them into light, and then, blasts them across these incredible distances. Okay, so let's unpack this a little. When we run audio through copper, we hit a physical wall.
You do.
The signal starts to degrade after, maybe a few hundred feet because of things like resistance and capacitance. But here's where it gets really interesting.
And noise.
The noise. The biggest enemy in any live environment.
Exactly. I mean, copper acts like a giant antenna. It just soaks up every bit of electromagnetic interference, EMI, RFI from power lines, lighting rigs,
Everything.
radios, anything nearby.
Yeah.
And that sound, that just translates directly into hums and buzzes right in your pristine audio signal.
And fiber optics.
It's just transmitting light. It's 100% immune to all that electrical noise. That purity is the real game changer.
So when we talk about distance, we're not just talking about getting across a stadium without losing signal. What's the operational difference we're looking at here?
The scale of the upgrade is just staggering. I mean, it's what delivers the savings.
Right.
With standard single-mode fiber, you're looking at runs up to 20 kilometers.
20 kilometers. That's over 12 miles.
12 miles, yeah. And with special options, you could push that out to 120 kilometers.
Wow.
And just for contrast, multi-mode fiber can do about 3,000 feet, which is still a huge boost over copper. And the quality, it's perfect. 16-bit, digitally encoded, broadcast quality audio.
So the full range of human hearing, 10 hertz to 20 kilohertz.
The full range, no loss.
Okay, but I have to ask. If we're swapping out this big, robust, thick copper for what is essentially a fragile strand of glass, aren't we just trading distance for, a lack of durability?
That's a really important question. But modern fiber cable assemblies are incredibly robust. What's really fascinating here is the trade-off in weight and bulk.
Okay.
You're taking 16 individual heavy audio cables and consolidating them into a single optical cable that's as thin as a hair.
Right.
So imagine the load-in for a major festival, getting rid of thousands of pounds of copper trunking. That's not just an equipment benefit, that's a huge labor and safety benefit.
And the whole system is designed to be easy to use, plug and play.
Exactly, which tells you that rapid deployment is a top priority.
So let's connect this to the real world. Think about routing audio from, say, a distant interview booth across a massive NASCAR track.
Or a sprawling theme park, yeah.
Ugh.
Those setups are they're impossible with traditional copper. This F-16A XLR-TxRx is a 16-channel unit, which is essential for these huge environments. We're talking rental, staging, concerts, broadcast.
Anywhere distance and noise are critical factors.
Absolutely. And this tech guarantees that high-quality transmission using optical fibers with specialized connectors. You'll see things like SDPC, SCPC, or FCPC.
Hold on, for anyone listening who hasn't worked with fiber, what are those, practically speaking?
They're just different types of plugs, really. They're common physical interfaces to secure the end of the cable and make sure you have a reliable, low-loss link.
Yeah.
They're just the standard connection points that keep that light path totally pure.
Excellent. This really does feel like a crucial step forward for pro-AV infrastructure.
It is.
So that brings us to our final provocative thought for you to chew on. The meantime, between failures, the MTBF, which is basically how long you can expect this system to run nonstop without needing a repair, is rated at over 100,000 hours.
That's over 11 years of continuous operation.
Exactly. So if you were planning the next generation stadium or concert venue, how might that phenomenal level of reliability, combined with this total freedom from distance, fundamentally change the entire physical design and scope of your infrastructure project?
Something to think about.
That's all the time we have for this deep dive.